નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 10th, Subject Science, Chapter 3rd, Metals and Non-Metals. So dear students, today we will discuss how do metals and non-metals react. See, you know that in the above activities, in the previous activities, we saw that reactions of metal with a number of reagents like air and as well as acids. So like this, I have seen the activities. So why do metals react in this manner? Why do metals react in this manner? Do you know that some of the metals are reacting very fast? Some metals are not reacting also. Some of the metals are reacting less. So like this, why it is like that? So it is because of that. Let us recall that what you learned about the electronic configuration. So what do you mean by electronic configuration? Distribution of the electrons in the atomic orbitals or molecular orbitals. So that you have learned in the 9th standard. Okay. We learned that noble gases. Noble gases means which one? See, here I have written helium, neon, argon. See, they are called noble gases because their atomic number you see in the outermost orbital it will be stable. So it will become stable configuration will be there. 288 forms will be there. 28 or 288 forms. So that is why they are less reactive. So they will not go for any reaction. So that is why they are, what you are saying, inactive metals. Inactive gases you are saying, noble gases, inactive gases. Okay. So this one, which have completely filled valence shell. In the outermost orbit, completely filled. Okay, outermost valence shell is completely filled, 288 form. So we have completely filled valence cells, shows a little chemical activity, shows the little chemical activities. So no reactions. We therefore explain so that is why explaining the reactivity of the elements as a tendency to attain a completely filled valence shell. So reactivity, how it becomes, dear students? Tendency, see, elements as a tendency to attain a completely filled valence shell, trying to complete the valence shell. Okay, in this way reactivity shows. So let us will understand with the electronic configuration of some of the noble gases and some metals and non-metals. See here I have written down. See noble gases, helium. See the element names helium, neon, argon. So here atomic number you see 2, 10, 18. So here outermost orbital see here 2, K shell. You know that the shell will be there. Say like this way shells. Okay, this is 1, this is 2, this is 3, this is 4. So like this here K shell, L shell, M shell, and as well as N. This is the outermost, and here nucleus will be. And see in this first K shell will be 2, and here 2, 8. So K and L shell will be 8 is the outermost orbit in this neon, and argon will be 288. So M shell will be the outermost orbit. Correct or not? So these are the two of if the outermost shell configuration is stable, then this will be less reaction, not there, least reactive. Okay, then you see the metals now. See the metals, sodium, here I have written 11, 281 will be there. Magnesium 12, 282. Aluminum 13, 283. See here, you have seen that in the shell, say for example sodium, 281. 281 in the M shell only 1. And here 282 in the M shell will be 2, and here 3. So that is why they are more reactive. Dear students, they are more reactive. Why? Because they are not stable. Their outermost orbit is not fully satisfied. So that is why these are outermost configurations. Whose outermost configuration, electronic configuration is 1, 2, 3. They have to lose their electrons. They have to lose their electrons and then become positive ion. They become positive ion. And you see the non-metals now. Here you see that 7, 2, 5. Here outermost orbit is 5, 6, 7. So here they have to gain the electrons. So they become negative. Say 5 is only for 8, only 3, 6, 2, 7, 1. So like this, they have to lose. They have to gain the electrons. So they become negative ion. So in this way, they will balance the valence shell. Okay. So now we see that example now. So we can see that sodium atom has one electron in its outermost shell. So you know that here sodium atom has one electron. Sodium has one electron in its outermost shell. So 281. So what will be said? If it loses the electron from its M shell, see here M shell, if it loses, one will be there here. So if it loses one electron from the M shell, and that will become stable octet. See here, it will become stable octet means what? They will become 28. So they will become 28, stable octet. Okay. The nucleus of this atom still has 11 protons. See, you know that nucleus, here this is protons will be there, that is 11. See, because you know that how much protons will be there, that much electrons will be there. See, proton will be 11 only, but electrons will be changes. Because when it, electron still has 11 protons, but the number of electrons has become 10. But the number of electrons becomes 10. Okay. So there is a net positive charge. So it becomes the net positive charge will be there. Net positive. See, look at now. It becomes a net positive charge giving a sodium cation. So giving a sodium cation. So Na positive we are saying. What you are saying? Na positive. Okay, now look at this one. See, this atomic number of sodium is 281. So it has to lose the electron so that it becomes stable. Okay, becomes stable when it should lose the electrons. So it becomes now 28. So one electron losing. So it becomes one electron losing. So in this way you have to write. See, losing here one electrons. So it becomes positive. So this we are saying sodium cation. In the similar way, chlorine, on the other hand, chlorine you see has 17 electrons. How much electrons will be there? Chlorine has, on the other hand, chlorine has 7 electrons in the outermost orbit. So atomic number chlorine how much? Atomic number is 17. 2, 8, 10 plus 17. Okay, 7 electrons will be there in the outermost orbit. So, outermost shell. And it requires one more electron to complete its octet. So, to octet form, octet means 8. One more electron is here. So, that's why it is gaining 1 electrons. It has to gain 1 electrons. And the electron lost by it requires one more electron to complete its octet. So, then it becomes a negative ion. So, that's why chlorine ion we are not saying, chloride ion we are saying. So, it is 2884. Okay. Now, if sodium and chlorine were to react, see, sodium and chlorine were to react because here one is giving and one is losing. So, giving and what we are saying? So, give and take relation, give and take relations will be there. Give and take relations we are saying. So, if sodium and chlorine were to react, the electron lost by the sodium could be taken up by the chlorine. See, electron lost by the chlorine could be taken up by the chlorine. Okay. And the chlorine atom gets a unique negative charge. So, chlorine will be negative charge only because its nucleus has 17 protons and there are 18 electrons in its KLM shell. So, then it will be, because it is gaining, so it becomes 18 electrons in the KLM shells. So, this gives the chloride ion or chlorine. So, this gives the chloride ion we are saying. Okay, then, so both these elements can have a, so both these elements have a give and take relations. So give and take relation between them. So give and take relations. So this is the formation of, so what is this? This is the formation of the sodium chloride. So in this way you have to show the figure. See, one electron is joining here. 2, 4, 6 and 8. So like this way here also Na positive and this is the chlorine. So like this structure you have to show it, dear students. Okay, this is the formation of the sodium chloride. Now you see the second example on the other hand. Let us see sodium and chloride ions being oppositely charged. They are being oppositely charged and attract each other and are held by the strong strong electrostatic forces. Strong electrostatic forces. Okay. So you know that sodium and chlorine, so attract, here they will be attract. So there is an attraction and become strong electrostatic. So they will make a bond here, they will make a bond, and that bond you are saying that electron valent bond, or you are saying, what you are saying, electron valent bond you are saying, or ionic bond you are saying, that ionic bond or electron, what you are saying, valent bond. So it should be noted that sodium chloride does not exist as a molecule, but aggregates oppositely charged ions. Okay. So this is the one. Now you see the another formation. Let's see, you will see the another example of this. One more ionic compound, magnesium chloride. See, magnesium chloride. See, magnesium atomic number, you see, magnesium atomic number is 12. So 2. So it has to lose 2 electrons, so become 2 positive charges. See, here we have to write like this. See, the atomic number of magnesium is 282. 10 plus 2, 12. And it has to lose 2 electrons, then it becomes an octet form. Okay, so that's why here losing 2 electrons, and that's why here magnesium 2 positive. And here you have seen that another formation is the compounds here, chlorine, magnesium chloride. How that you know that chlorine? Chlorine is 287. Atomic number is 17. And 1 electron is gaining. So that's why you have to write here. See, you have to write before the element. And then 288 forms. So then becomes an chloride ion. So what it will be? Chloride ion. See, try to understand here, students, how to write here magnesium cation because positive, and here chlorine is negative. So that's why chloride anion you have to say. Chloride anion. The compounds formed in this manner. So like this way, see the figure also like this. The magnesium 2 and here chlorine 2, 4, 6, 7 and 8. And here also because 2 positive charge will be there. And here also 2, 4, 6 and 7. So 1 will become 8. So then you have to show like this. So here 2 because here 2 will be there. So this. So you got this magnesium chloride MgCl2. Formula is MgCl2. So this is the formation of magnesium chloride. See, this is the formation of magnesium chloride. So the compounds formed in this manner by the transfer of electrons. So how it is, students? This is because of transfer of electrons. See, transfer of electrons formed from a metal to the non-metal. See, these are metals. And this chlorine, this is non-metal. From a metal to the non-metals are known as ionic compounds or electrovalent compounds. So dear students, you got one more definition here. So what do you mean by ionic compounds or electrovalent compounds? The transfer of electrons from a metal to the non-metal are known as ionic compounds or electrovalent compounds. Okay, dear students. So we have completed now how do metals and non-metals react. Okay, so we'll see that in the next video, the properties of the ionic compounds. Okay, students. Thank you. Bye-bye. Thank you for joining us.